Hi folks, so in this video what we're going to do is a question from the 2016 Junior Cert Technical Graphics exam. It was from the old course, and this question specifically involves the area of transformation geometry. So what we have, it says here, is the figure shows the design of a video game character. The shape is subject to transformations in the following order. We have to do number 1, a translation, number 2, an axial symmetry, number 3, a central symmetry, and number 4, a rotation clockwise through 90 degrees. P1, P2, P3, and P4 show the positions of point P, which is given here on the character. You can see it down here at the bottom right. Show the positions of point P under each of these transformations. Part A, draw the given figure. Part B, determine the image of the figure only under each of the transformations as they have listed up here. So what we're going to do is we're going to have to take from P to P1, we're going to do a translation. So it's going to just move along like it's moving along a set of train tracks. From P1 to P2, we're going to do an axial symmetry. From P2 to P3, central. And from P3 to P4, we're going to do a rotation clockwise through 90 degrees. Okay, so starting there with part 1, we're going to draw this figure. And based on how it's going to move about the page, it's kind of moving, you can see here in this general direction. What we're actually going to do is we're going to draw this down here roughly on the left-hand side of our page, on the bottom left-hand corner. Okay, so we can see here, if we just break down the figure, so I'll just move in here, just grab the page, stuck to my board here, apologies. So, if we break down the figure, we've got a circle of radius 26, and then from the center point down to the bottom, it kind of looks like a mushroom. From the center point down to the bottom, that is a distance of 31 millimeters. And then it tells us that the base then is a distance of 30 or a length of 30. So that means we're going to measure out 15 to the right and 15 to the left. And it tells us here we have to find out the radius. And you can see here they give you a little guideline where you connect the bottom part, let's say, of the stem over to the 3 o'clock position on the circle, and where it cuts through the vertical line here. You can see the vertical line above P, that there works out our radius, okay, with the center point here at the bottom of the stem. So that's what we're going to have to start drawing off. Okay, so on the bottom right hand of my page, I'm going to start that drawing down here. So I'm just going to move the screen or the visualizer here a little bit. Okay, I'm going to start it roughly around here. So I'm going to start off with a line like horizontal line and the vertical line going through it. Okay, and that's going to be my center point for the circle, and I'm going to measure out 26 on that. So there's my 26. I'm now going to draw in my circle nice and lightly. So there's my radius 26 circle. Now from the center point, I'm going to measure down 31 millimeters, 3.1 centimeters. From the center, I'm going to do a line through that point, and I'm going to measure 15 millimeters to the right, which technically gives me point P, and 15 millimeters to the left. Using my set square now, I'm going to do a vertical line on the vertical line, and then to figure out the radius for the arc going inside here, which the center point is right here, I connect the bottom left point here to the 3 o'clock position on the circle, where it cuts through the vertical line, where this inclined line cuts through the vertical line. You can see a point right there. The distance from here to there is my radius for that arc. So what I do now is I position the compass on this point, move it out to here, and I draw the arc through that. Now I just like to use a marker just for my demonstration and to heavy it all in. Okay, so just bear with me there a second. So switching out. Just this slightly. There we go. Okay, now just going to heavy in this portion. So there's that portion onto the inside curve. Okay, and now we're getting on to the stem. So that's the first part of the question. Just drawing the actual figure. And now that I've drawn the actual figure, I will also label this point here, point P. Okay, now what we have to do, having completed the first part of the question, we have to complete the rest of the transformations given the structure, which was we're starting with a translation. So if we could just come back to the page here, and we look at the page, we can see from point P, we have to locate point P1. That is a distance from P of 45 millimeters moving horizontally to the right, and then measuring up vertically a height of 100. So that's what I have to do. I have to find P1. So what I'm going to do from P, I'm going to do a horizontal line out. On that horizontal line from P, I'm going to measure 4.5 centimeters or 45 millimeters. And then I'm going to do a vertical line going upwards. Okay, and I need to measure 100 millimeters. So I'll just adjust my camera there now. Now, from 0 up as far as 10. There we have it. That there, I've made the little mark, I've measured up 100 millimeters along that line. That there is point P1. Now, what I have to do is I have to move this object like if it was moving on train tracks, because that's the translation. We're going to move from P up to P1. So, step number 1. What we want to do is we want to connect P to P1. And that is the direction that every point on the object is going to move at. Okay, it's going to move parallel from P to P1. So we're going to use a lot of sliding set squares. Now, the good thing about this one for the translation is that everything on this object, if I was to redraw it up here, starting with P1, okay, I could actually do it. I could measure out 30 and get the stem and do the lines up and so forth, okay? But what I will do is the most important point on the object is the center point of the circle that has a radius of 26. So parallel to P to P1, from P to P1, I'm going to do sliding set squares. So every point on the actual object is going to move parallel to the direction of P to P1. So the center point also moves up parallel. Okay? And the distance that it moves is the distance from P to P1. Every point on the object will also move the same as the distance from P to P1. So I set the distance from P to P1 on my compass. I position it on the point, so the distance from P to P1 is now got on the compass. And I move it up to the point that I want to find, which is the center point. Swing an arc, and you can see that is the new position of my center point. Now what I want to do is, I take the radius, which was 26, same as the radius from down here. I can take that radius from down here. I can put it on the center point, and I can redraw my circle, nice and lightly. Okay, so now that I've redrawn my circle, what I can do now is I can actually put in the axes once again, the horizontal line going across the middle. The vertical line going down through the center. Okay, and then I can put in the stem line. From P, it will go vertically up. And then from P, it would also go horizontally across. Now, how would I find where it ends here? I can measure 15, or if I wanted, I could do the sliding set squares method again. So, parallel to P to P1, from P to P1, sliding set squares over to this point here, bottom left of the stem. And you can see where it cuts through right there, that will give me the other leg of the stem. So from there, I could do a vertical line. Now I've got the other part of the stem. I'm just measuring that. There, about 29.5. My accuracy is a tiny bit out there. That's the challenge with these questions at times. Let's check this one. That one there is saying 14.5. Okay, so I'm just a little bit out on that, but that's okay. Sometimes the challenge in these questions is staying 100% accurate, which is quite a bit of a challenge, okay? Now, next part, I want to figure out that arc again. Now, I already have the radius figured out, so I could simply take that from down here. Okay, I could simply take the radius from down here, take that guy, the radius there, and bring it up and redraw it. It's possibly the easiest way. Just making sure that it's the exact same as the one down here. Yeah, there we go. Now that I've got that drawn, once again, I'm going to heavy it in. So that is our first translation, or sorry, our first transformation, and it was a translation from P to P1. Heavy in the horizontal, then the two verticals. And now I'm going to use my compass to heavy in the arcs. Okay. Just making sure I have the right measurement on it. So there we go. Then the arc on the inside. Okay, so there we have it, guys. That is our first transformation where we have completed the translation from P to P1. And you can see the object is simply just moved parallel of the distance from P to P1. Now what we have to do is we have to locate point P2 and we're going to do an axial symmetry. So to find P2, from P1 I have to work out the distance. So you can see it's from here over to here, which is a distance of 60 plus 45, so that's 105 to there. And then from here it goes up, and it's up a height of 40. So 105 to the right, up 40 then. So from P1, I'm now going to measure 105 along that line. So 10.5 from P1, taking the distance there. And I'm going to mark up a height of 40 millimeters. So that would be, if I'm on the 7, bring me up to 40, that would be up as far as the 11. Okay, there I have it. That there now, right there, is P1. Or sorry, P2, apologies. So that now is P2. And for P1 to P2, we have to do an axial symmetry. So they've already given us the position of P2. Okay, we have P1 here, they've given us the position of P2. We have to now create an axis. So to do that, what we're going to do is we're going to connect P1 to P2. Connect P1 to P2 like that. And then step number 2, we have to bisect that line to create our axis. So P1 to P2 is connected. Put my compass on P2, pick a distance greater than halfway, swing an arc above the line, below the line, keep the same distance on your compass, move it over to P1, and swing an arc to cut those two arcs that you previously did. And where the arcs cut each other, that will help us create our axis. So, draw that in there now. Put my set square on it. There we go. So, there we have it, folks. There is our axis for P1 to P2. And now what we have to do is we have to complete the transformation whereby we're going to flip this over the axis. And it's not going to look the exact same, it'll just be symmetrical. So it's going to come over here and it might be slightly going like that. Okay, if it was like this, it's going to be slightly like that. Okay, tilted in towards the axis. Okay, so what I have to do once again is bring over the important points. Now what everything has to do here is that it has to go perpendicular to the axis. Okay, and what I mean by that is if you look at the axis line here, okay, and if you look at the line connecting from P1 to P2, that line connecting from P1 to P2 is perpendicular. So I can use that as a guide. So from P1 to P2, the points that I need to bring are once again the center point. Just want to bring out the center point. So the center point will come. I'm also going to bring this point here. I'll probably have to go to the opposite side. There we go. And then using my compass, I take the distance from the axis to determine those points. So P2 has already been found. If I want to find the center, I put my compass on the axis. I set the distance on my compass as far as the center point of the circle on this side. So make sure you're 100% on the money. So these questions are a bit of a challenge to be 100% accurate. So there's the center, and I need to mark it out to the opposite side. So I've now found the position of the new center. Likewise, I could also find this point out here. So there's that point, and there's that point. Okay, now what I'm going to do with my compass then is just adjust this slightly on the screen so you can see it a bit better. Apologies. Now what I'm going to do is I'm going to take the radius from back here, the original 26, I can take from this one, might actually take from down here. Using this new center point. So there's my circle. Now what I need to do is I need to get the stem. Okay, what's helpful here is because I've located this point, I can connect, I know P1 connects that point, therefore P2 also connects it over here. Now, so I've now got the base, and what I need to do is I need to look at the geometry in relation to the object. First of all, what I know about the base then is the base, okay, is parallel with the line that is running horizontally across for the axis, okay, and then the stem is perpendicular to the axis of the circle, the horizontal axis, okay. So I need to go perpendicular to this line to find the stem. How do I do that without having to actually find exactly? I could project out these points, but it can become a little bit awkward. I simply want to find that line. That's the way I'm going about completing it. And I'm recognizing that this line here is parallel with this line. So what I want to do is, using the line on the base that I found, I can do sliding set squares parallel to this line here. Okay. Using sliding set squares, I can go parallel through the center point of the circle. Now, to find the stem and the legs, okay, of the mushroom, okay, as it goes up, what I know is that this line here is perpendicular to that line. So I need to go perpendicular to this line. Now, there's a couple of ways you can go about this. You can put your compass, or sorry, your 45-degree set square, the long edge of the 45-degree set square on the line you want to go perpendicular to, and you can rotate the set square, and that way it'll work. Okay, and you can draw on a line then from P2. Okay, the other method that people often quite like then is if you get your set square here like this, I'll just move over a little bit on the screen so you can see it a bit better. If you get your set square like this, say the 45-degree set square, I'm going to put it up now just because the visualizer is getting slightly in the way there to adjust the camera. Apologies. Put the number side of the 45-degree set square on the line you want to go perpendicular to, which is in this case the axis line. I'm going to put the number side on it, put the other set square, okay, at the side of it here. I'm going to put the other set square at the side of it here, and then I'm simply going to slide it up, okay, and you can see there you can go perpendicular to it as well. And that'll help you also draw that line there, okay. So that's another way you could do it. The way I like to do it, as I said though, is I put it on the axis line that I want to go perpendicular to, and I simply then hold the one underneath it steady, rotate the set square that way. And now that I have that, I can draw on my stem. Okay, now that I have the stem drawn, I can actually, and I've actually got the center point I should say, so I'm going to go perpendicular once again, apologies, need to do one more. From there, I'm simply going to go like this, through the center, put my pencil on the center, I need to find the center point at the bottom. Okay. Now that I've found the center point at the bottom, I'm going to get my radius for this guy down here. If you remember, just pull this down a little bit slightly there, guys. Sorry. The radius for the arc down here. So from the center down here, okay, to get that radius, so I can bring it across and draw it in once again. There we go. Quite happy with that. Once again, I want to heavy in the important parts, okay, to make it stand out. These questions, especially the circular ones, do get very challenging at times. just in the overall neatness of them. Okay, so there's the arc there. Put in the second arc now. So there's the second arc, and then the stem. Okay, so there we have it, guys. We've done a translation from P to P1. We've now done an axial symmetry from P1 to P2. Now we have to do a central symmetry from P2 to P3. So we have to find P3. So where's P3 in relation to P2? So from P2, you can see it's a distance over here. What distance is it? And it's in line with P1, which is helpful. So all we have to do from P1 is we have to extend it out. But what is the distance that it's extra underneath P2? It is a distance of 80 millimeters. So on the line that we'd already drawn from P1, I can extend it out a little bit further. And I'm going to measure from here 80 millimeters. 0 to the far as 8. So I've got my 80 millimeters there. And that then is my P4. Now this is going to be flipped over. So right about here. So that's, sorry, P3. Apologies. Now, what we need to do is we need to find our point of central symmetry. So they've given us P2, or sorry, we have P2, they've given us P3. I have to find my point of central symmetry. So once again, we're going to bisect. So connect P2 to P3. What we're going to do then is we're going to bisect that line to find the point for central symmetry. So using my compass, set a distance from P3 greater than halfway. Swing an arc above the line, below the line. From P2, same thing, above, below. You can see those two arcs where they're crossing each other. I'm now going to connect those to find a point in the middle. That point in the middle, I'm going to give it a letter. I'm going to call it C for central symmetry. And now I need to find all the other points that are relevant to the object in relation to me, okay, or in relation to the object through C. So from the center point of the main circle, which has a radius of 26, from there, I'm going to go through C, from that, through C, and line it up out to the opposite side. So from there, through C. Okay, and I've done this one. The other one I'm going to find is this one here, at the bottom of the stem. Same principle. Okay, now the distances I want to take. So I take the distance from the center point, C, to the center of the circle, which is that distance there. And I'm going to mark it out onto the correct line, which is that one. Now I'm going to take the distance from C to the other point on the stem, at the base, that distance. And once again, mark it out. Now that I've got them 2 points, that one and that one, I'm going to go back to my original guy here. I'm going to take the radius of 26, draw on my circle, put it onto the center, my new center for P3. So there we have it. There's the circle. I'm now going to connect up P3 to the other point on the stem. That point is very important because once again, as I said to you previously, like we did in the axial symmetry, this line here at the base of the stem, which I have now got over here, is parallel to the axis. And then I want to go perpendicular to that axis to get the stem. So parallel to this line here that I've just found, that line there, using sliding set squares, parallel to that, I'll slide it across so I get to here. Okay, and then doing the method, I'm going to zoom out here. I'm going to rotate the screen a little bit. I'm going to zoom out a little bit so you can see how I do this. So from this point right here at the base of the stem and this one, okay, with the set square set up like this, like that, I'm going to rotate my set square. So I get the long edge of 45 and I rotate it. Then from P3, drawing my stem as far as the axis. For the other base point of the stem, drawing my axis. Okay, I have everything I need now except the last arc, which once again I'm going to take from the guide that I worked out over here. So from here, take the original distance for the arc. There we go. And I can actually put it on the center point. Sorry, excuse me, that's not the center point. I actually need to find that. So be careful. The center point will be from here. Now. So it's from this center point here. Make sure I have the right one. Yeah, it's this one here. Through C. So I can find it right there. It's really important. Didn't mix up that. So it's right there. Now, as I said, I'm going to take the radius for this arc here from the original, the first model. There we go. Put it on my new center, which I've now found. Okay, just right there. And draw in my arc. Okay, so now that I've done that, once again, start drawing it in. I'll go heavy up as far as the arc. As far as the arc, I'm using the compass then to heavy the rest of it in. Just that side. Okay. Just focusing on being neat and tidy. Any graphics question on the old technical graphics course, there's always going to be marks for presentation. So there we have it. There is our third transformation. We have now done central symmetry, and now we're on to the last one, which is a rotation from P3 to P4. So what we have to do now is we have to find P4. So to find P4, you'll actually see, if you just zoom in here in the question, if we go to the original model, from the center point of the original circle, you can see here it's in line with that. We're going to do a line over. And what is the distance over? It's a distance of from here, from P, or even from P1 line, from the 45, because we have that line, I can measure over 60 and do a line up. Okay, so from the original, zoom out here, it's in line with the center point of the original one. So, doing a line across here. Okay, and if you remember, we measured already 45, so from this point right here, I'm going to measure over another 60 millimeters. And there we go. I have now found P4. So P4, labeling that there. And it says here we have to do a rotation clockwise through 90 degrees. So what we're going to do is we kind of have to make a little triangle. So if I was just to do a quick little sketch up here, what we're going to do is we're going to make a little triangle. And imagine, based on my triangle, just do a little sketch there, like that. It's going to be an isosceles triangle. Now, the rotation point is going to be the point at the top. We're going to call that point R. Okay? And if you imagine, this point over here is the one we're trying to find. That is P4. This one is P3, which we already have. We have P3, we have P4, and we don't have the rotation point. Okay? And they tell us in the question we're rotating clockwise. So it's going to move from here over in this direction, because that is clockwise. Okay? So our rotation point is going to be somewhere up here, if you imagine you're making a triangle. So P3 to P4, we're going to connect the two of those, because they're connected here. So P3 to P4, I'm going to connect the two of those. Okay, so we're going to connect the two of those. And what we're going to do is we're going to use the principle of a triangle to help us out. Now, if the rotation angle is 90 degrees, that means 90 degrees is up here. Okay, that top angle is 90. Now, as I said previously, that the base angles, okay, it's an isosceles triangle, two base angles are equal. So if you subtract 90 from 180, that means the two base angles add up to what's left over, which is 90 degrees. Therefore, our two base angles, because they're equal, will both add up to 45. So what we're going to do is we're going to get our protractor. Okay, just grab my protractor here. We're going to get our protractor. We're going to position it on P4. Making sure the zero is resting on the line from P4 to P3, with the zero with the center point on P4. And we're going to measure an angle up as far as 45 degrees. Now that I've done that, I'm now going to draw on that line. And somewhere along that line is my point R. So I have to do the exact same with P3. Center point of the protractor on P3. Make sure the zero is resting on the line from P3 to P4 on this side, and I'm reading it around this way this time. 0, 10, 20, 30, all the way out to 45. So there's my 45 degrees, P3. And you can see there I've created a triangle, but most importantly, where the two lines cross each other at the top, I've now found my rotation point, I'm going to call that R. Okay? And that is the point that I'm going to rotate all the points about. Okay? So there we have it, folks. Now what we're going to do is rotate all those points, and once again, I'm going to stick to the previous points that I've been rotating. So zooming in there now, a little bit better so you can see it. Okay, so just get this out of the way. From R, P3 has already been rotated. So from R, I'm going to rotate the center point. So this is the next one I'm going to do. Center point is going to compass to there. That's the first one I'm going to do. Get all the way around. Now what I have to do, I have to connect R to the center, like this. Connect R to the center, like that. I get my protractor and I put it on that line. So my protractor is sitting on R. Make sure the zero is sitting on the line connecting to the center. Just have to adjust this slightly. Center point of protractor on R, zero sitting on the line. Okay, and I'm reading it around to 90 degrees. All the way 80, from the zero where it's sitting on the line, all the way as far as the 90. Right there. And now from R, I'm going to connect the line through that. And somewhere along that line, and where the arc intersects, is going to be my center point. So you can see clearly there, I actually have to rotate it a little bit further. So using R again, back to the center. I have to rotate this a bit further. There we go. So I've rotated there now, and I've now found, once again, the center. Okay, and the other point that I'm going to use again, once again, is this point down here on the stem. So from R, I'm going to connect it to that. I'm going to rotate this point around. So rotating that around. I'm going to rotate that around. After I rotate it, connect R to the point. Then I'm going to use my protractor, put it on the center point, which is R, and then make sure zero is sitting on the line resting to here. So quite happy with that, yes. So from zero, around as far as the 90 degree mark, right there. Happy with that. Then connect the line across. There's my point. Okay, and once again, that's the basis then. I'll actually draw that in. Okay, because that line is going to be parallel, as we've already discovered, with the axis line, okay, of the circle. So now using my compass once again, I'm going to get the radius from the original. Let's go here, put it on my center, draw on my circle. There's the circle. Now what I want to do is I want to get the axis going through the circle. So parallel to the stem, sliding set squares. So use your sliding set squares to go through the center point of the circle. Then rotate your set square, which you've seen me do already. Put it down here a little bit so you can see it here. So perpendicular to the axis we've just done, I'm going to rotate my set square. And from the stem, there we go, that point, and then easiest way for me to find the center for my arc down here is just actually go through the center as well. And there we go. And zooming back in, just take it out a little touch. There we go. Now, I need to get the arc cutting through it. So once again, going back to my original model, take the radius from there to there. Put it on the center point I have here at the base. Okay, and finally then, switching out to my marker just to make things stand out a little bit clearer. Just looks a little bit better on the screen. We're essentially finished the question now. So, starting off with the big circle. Come as far as there. And all the way around. As far as there. Same with the arc here. Okay. And then heavy in the base, which is where the stem is. Okay, so there you have it, folks. That there, guys, was the question from the 2016 Junior Cert Technical Graphics exam based on transformation geometry. Transformations, okay. The challenge in this question was trying to be accurate with the stem throughout, and I think the best way to be accurate, if you went off trying to find all the individual points, you can do that, but it can make it quite tricky. And the best way to be accurate there, you could see, was once I kind of recognized that the stem base was parallel with kind of an axis line, that was kind of my guide on every question. And you can see that each one does look, okay, quite accurate there. Okay, I'm quite happy with how that turned out at the end of the question. The challenge with these guys is always going to be staying accurate and trying to make sure that the original model, or sorry, the last transformation, which in this case was a rotation, looks like the original model. Okay, so there you have it, folks. That was the 2016 question from the Junior Cert Technical Graphics exam. Hope you found it helpful.